All right, here we are back with part two of the generative model for music, a little expose of the Jukebox AI model suite. In part one, we just went over some basic terms, just generally got a sense of what we will be looking at going forward. So today, let's talk about how are the samples actually generated. We got three VQ-VAE models, which we've explained earlier, the vector quantized variational audio encoders. These are essentially just to make a codebook. We want to produce a codebook from a data set of audio. Then we want to train a model to generate the lower levels from the higher level codes. Then we want to train a model to use conditioning information, which is perhaps timbre, genre, tempo, lyrics, and we want to format the codes with the conditional information as input. Then we want to ancestrally sample. We want to use ancestral sampling to token by token generate these samples. The three VQ-VAE models. Again, as I said, we're creating a codebook of vectors. This codebook of vectors allows us to generate samples from a lower dimensionality than the actual input audio. So generating a codebook is a form of abstraction. We're taking a larger piece of information and we are resolving it to a lower dimension, hopefully representing the same amount of information. Instead of using one VQ-VAE model, they opted to use three. This allows each level or each model to have a different level or different degree of abstraction. This degree of abstraction is how much audio each token is to represent. And the amount of audio each token is to represent ends up being the temporal resolution or the hop length. The top level has the highest degree of abstraction. This means that the top level, you will see in the graphic, is the one with the largest chunks in the codebook representation. These chunks represent more audio, so it's harder to decode these large chunks meaningfully. So generally with only one model, you will end up with a system that trains a codebook equivalent to the bottom level. Doing that gives you a higher quality sound, but you lose some of the long-term information that you would get with a larger chunk of audio represented. On top of that, you're able to use less tokens per audio sample. And if you were to use a method of upsampling the larger chunks into smaller chunks, you would be able to create a reconstruction with high quality audio using a highly abstracted data representation. And that's what they did. They trained the three VQ-VAE models independently, each developing a codebook. Then they trained a separate model to learn how to reconstruct the lower level models, or the models with less abstraction or less of a degree of abstraction, from the top level model. Okay, so let's take a step back and see where we are. Currently, we have three VQ-VAE models. These models are simply performing the task of generating a codebook, with each model generating a codebook of different degrees of abstraction. The main end goal is to generate a single coherent piece of music. And now let's see how we get that done. So we got the codebook. We start with the top level, the highest degree of abstraction. We train the transformer model to generate the middle layer from the top layer. Then the same model trains to generate the bottom level of abstraction from the middle and top levels of abstraction. And that's what this formula represents. Alright, so we're done with the VQ-VAE model. Generated the code. We got a transformer that can take highly abstracted data and convert it into data with less abstraction. That is generating music. But they wanted to generate music of specific styles. To do that, they had to employ conditioning. They want to control the generative model by providing conditioning. The first model, they focused on the artist, the genre, the timing. They created labels to be added to the codebook and trained multiple transformers to learn these audio patterns and recreate pieces of music for the given artist, genre, and timing. Additionally, they wanted to add lyrics to these generated samples. Now, there already were lyrics generated, but they came out as babbling and incoherent. So to generate coherent lyrics, they trained another model to align lyrics to a chunk of audio. So the NUS Auto Lyrics Align, what that does is it allows you to upload a text file untimed, a non-timed, just a plain text file of lyrics, and it is trained to align these lyrics temporally in such a way that almost syllable by syllable, the lyrics will be displayed in conjunction with the audio in a karaoke form. So they use that and some other methods, which are honestly way above my pay grade, to generate samples of audio for a specific genre with specific, real, coherent lyrics that are timed accordingly. So now that we have all the models trained, we can actually begin sampling or generating these pieces of music. Let's go back to the paper because they formatted it pretty well. They start with ancestral sample. So this is the transformer setup to generate the bottom or the lowest level of abstraction from the highest level of abstraction. So they start with the top level that's selected by some way. They add some conditioning information and they're able to generate or upsample until they have a set of codes with the bottom level of abstraction that they can then pass through the decoder. To generate longer pieces of music, they do the windowed sampling. So they'll pass in a previous code and get the model to generate the next sample token by token as it did originally. And there's the prime sampling, which is taking an existing piece of audio, converting that into a set of codes, and then going through the sampling procedure to sample or to generate subsequent codes based off of the existing piece of audio's code representation. So that brings us to the experiments, which is where we're going to end it. We went over the models and the hierarchy of the models, starting with the VQ-VAE, going to some transformers, getting some conditioning, combining all that together to allow a separate model to take a segment and generate a new segment. This is a huge collection of models. A huge amount of work went into this. I'm just here to give a super high level, basic overview of it. I will show some examples of the samples that have been generated in future videos. I hope you have a fantastic day. Thank you. Please like and subscribe. Comment, make a response video. Any questions you have, I'll answer them. If you see something that I should have mentioned but didn't mention, or I got something wrong, definitely tell me, correct me, call me out, and bees. Peace.